Greetings, everyone, and welcome to Cota Access. Today's webinar is about medicine at the edge. I'm going to introduce Cota Capital. We are a technology investment firm that partners with exceptional teams to build and grow timeless companies, enabling the future. We have invested over $1 billion in more than 100 modern, private, and public enterprise technology companies. This webinar is part of Cota Access series that offers in-depth, market-driven discussions from featured founders, thought leaders, and leading executives, exploring cutting-edge business and technology trends that fundamentally impact large enterprises. My name is Kian Beyzavi. I'm a venture partner at Cota Capital, and it is my pleasure to moderate this panel with our esteemed panelists. So before we dive into the discussion, I wanted to take a few minutes and talk about what computing at the edge and medicine at the edge really refer to. So Gartner defines computing at the edge as bringing computing power close to the data source, to the application, and to the user. That means that instead of having to beam the data from the device to the cloud every single time, waiting for it to get processed, and then have the results travel back through the network to the user, you can run the analytics at the point of application. So what does that mean in the context of medicine and clinical practice? It means bringing more of the analytical power to the medical device, close to the patient, which is where the data is getting generated, and close to the clinician, where the results are being used. What are the benefits of computing and medicine at the edge? The main benefit is the ability to get real-time results. So reducing the latency, reducing the delay that would result otherwise from data traveling to the cloud and back. Another potential benefit is reduced processing and storage costs. And then finally, the analytics can still operate even if the connectivity to the network is intermittent. You're still connected to the cloud for storing the results and key information, but that is substantially fewer data points than it would be otherwise if you had all the raw data going to the cloud. So then the question is, why now? One reason is the exponential growth in the number of health devices and the volume of healthcare data that's being generated. According to RBC, today, approximately 30% of the world's data volume is being generated by the healthcare industry. Since 2013, healthcare data has doubled every year. And this trend is going to continue such that by the year 2025, the rate of growth for the volume of healthcare data is going to outpace other industries such as manufacturing or financial services or media and entertainment by about 10%. So where is all this data getting generated? Well, one major area are the wearables. Today, we have about 1 billion wearable monitoring devices worldwide, and they monitor anything from physiological to behavioral variables, and that number is only expected to grow. In fact, the number of monitoring devices for chronic conditions will triple by the year 2030. There are also vast data sets getting generated from genomic tests, from electronic health records, as well as in clinics and surgery rooms. Today, we will hear from 3 of our portfolio CEOs on the way their products are generating data in the clinical setting. So overall, it's staggering to think that healthcare data volume is already 2.5 times greater than the capacity of all of global data centers combined. But the driver of edge computing and medicine at the edge is not just storage and space. The delay I mentioned in sending the data to the cloud, waiting for it to get processed and come back through the network, significantly limits the utility of potential applications for healthcare. It would be unthinkable for a surgeon to wait 10 minutes during a surgery for the computer to help her decide where to cut next. So that is why today we are talking about products and technologies that really bring computing power closer to the patient and to the clinician, and thus enabling a whole new set of use cases, as well as leading to significant clinical benefits. The flow for our discussion today is I'm going to start by introducing our illustrious panelists. We will have a discussion around industry trends, enablers, drivers, and potential hurdles, and also their vision for the future. I encourage you all to submit your questions through the chat function, and we will incorporate them throughout the conversation. It is always good to anchor discussion of new emerging technologies in actual problems that they intend to solve. So we are very fortunate today to have Dr. Kristen Stoudemire with us. Kristen is a practicing physician, surgeon, and a visionary thought leader. I'm going to share my screen. So she is a trauma surgeon as well as an associate professor of surgery at Stanford. Welcome, Kristen.
Thank you, Kian. Yeah, I really appreciate being on this panel today, and it's been great to be learning more about all these products. I guess maybe what I can do is say a little bit about myself and the types of problems that I face, and maybe that will lead in nicely to some of the other discussions. So as Kian mentioned, I'm a trauma surgeon, which means I take care of people who have injuries, but injuries that are so severe that they warrant admission to the hospital or operating room or ICU. I also do emergency general surgery. So in that category of practice, I don't do elective surgeries. So for example, if you go to a surgeon to have your hernia evaluated, I only do emergency cases or urgent cases that come to the hospital and have to be admitted. And then finally, I'm a critical care doctor as well. So I round in the ICU, and I'm the medical director of our surgical ICU at Stanford. So the span of my practice really covers all areas in the hospital. It ranges from being in the emergency department to the ICU, to the ORs, to the wards. And so in that, it's a nice practice to really get a broad view of what's happening through the hospital. And I also, the other roles that I play, I mentioned I'm a medical director for the ICU. I also nationally work on clinical informatics projects and also health systems at the national level around trauma. So I kind of have a smattering from being very focused on my clinical practice to national level innovations. So in thinking about what might help anchor the discussion, I can describe a little bit about the challenges that I face in my practice. They basically fall into two categories. One is on the emergency side and the high acuity side. There are clinical scenarios where I have to make decisions quite rapidly, and I have to make it on limited information. And the better information I can have, the higher quality information I can have, the faster I can have it, really helps me to make the right decision for the patient. And an example for that would be a trauma patient who might come in injured, very hemodynamically unstable. And I need to know, does this patient need to go to the operating room? Does this patient need something else? And having information such as bedside ultrasound can let me say, for example, the patient is bleeding in their abdomen and we need to go to the operating room right away. So those immediate needs that I have and immediate information is really helpful. So to your point about medicine at the edge, there's no time to have information go out and come back. I need to have that information right away. And then the other kind of bucket of areas where I face challenges are the challenging cases that we see in the operating room, where we might have some time to plan, but you never really know until you get in how bad things are. So, for example, what might be a very simple gallbladder case in an elective scenario where the person's gallbladder is not inflamed, it's very straightforward. We'll often get gallbladders that are terribly inflamed and we can't see normal anatomy. And so having something that can help move that case smoothly, efficiently, and safely is what I need. So of the two clinical challenges I face, I say the emergent quick decisions and then the planning in the face of challenges.
Thank you. That's great. Next, I'm going to introduce Amenikuzadeh. He is the he's the founder and CEO of Wave Health. Amin, please tell us a little bit about what your product do and some of the use cases and benefits.
Yes, thank you. Thank you for inviting me. Wave is a medical device company in Silicon Valley, and we're basically making ultrasound imaging accessible to everyone. We've created a super low cost, ultra portable, wireless ultrasound imaging system that basically pairs with your iPhone or smartphone and brings you imaging and basically turns your smartphone to a fully capable ultrasound imaging system. And if you think about it, over 60% of the world doesn't have access to imaging. And every 100 seconds, one woman dies from complications related to pregnancy. And we all know and have seen how much of an impact ultrasound has in managing pregnancy. And there are over 40 million healthcare professionals that still predominantly rely on stethoscope for their clinical practices. And we intend to change all of this and make ultrasound as ubiquitous as stethoscope is, and give basically eyes to clinicians into the human body. What I just showed you is a picture, an image of a beating heart. And believe it or not, it's not beating normally. And these are the kind of things that are very difficult to capture a lot of times with just a stethoscope, and ultrasound brings that visibility into the bedside. And in a nutshell, basically, we're bringing ultrasound to the edge, to the bedside, to the edge where it matters most. That's Wave.
Excellent. Thank you. Our next panelist is Todd Youssen, CEO of Active Surgical.
Thank you. Thanks, Kian. I appreciate it. Active Surgical was founded on our foundational technology of we completed the world's first fully autonomous robotic surgery of soft tissue. But before we get into building robots or doing anything like that, which is not our intent, we want to make sure that we're taking care of patients. The third leading cause of death in the world are preventable medical errors, of which 26% are preventable surgical errors. These are patients that are going to the operating room without a terminal disease, without a terminal illness. They're getting their gallbladder removed. They're having a colorectal procedure, a hysterectomy, a urological procedure, all serious to the patient, but none should be life-threatening, and none should be bringing these patients back to the hospital. Similar to, as I mentioned, autonomy. Think about the autonomous car world. And autonomous cars are providing, with machine learning, computer vision, and sensors, are providing safety, whether it's on your rear view mirrors or your rear view cameras, side view mirrors, seats that vibrate. We're doing the same thing in surgery. If you don't mind moving forward, Kian, with the technology. Basically, what Active Surgical is doing is we are providing physicians information and visuals that they cannot see any other way in surgery today. Today, the picture that you see on the left is a traditional laparoscopic view of doing a normal laparoscopic procedure that is called RGB, red, green, blue. The picture in the center, and some other technologies allow you to get fluorescent imaging. You can get that view. What Active does is not only shows you those first two views, but brings you what's called intelligent light. We are bringing through laser speckle technology intraoperatively in real time, the mixture of RGB, fluorescent imaging, and this technology all in one. What you see here on the left as you start playing, today, in order to see blood flow in a hospital, you inject what's called ICG dye. Anywhere that there's blood flow, it turns green. Where it's green, the doctor knows there's active blood flow. If you notice, we just clamped a vessel right here in the center, and the picture still shows green. That shouldn't be green because there's no more blood flow in that area. That's a false positive, and this is what doctors have been relying on for 70 years. If you notice the picture on the right, what ActiveSight does in real time, without any dyes, shows you where there's active blood flow and how much, based on that color heat map, how much blood flow. And when you release that clamp, you can immediately see the blood flow return. Why is this important? This is important to physicians because right now, one of the #1 causes of complications in surgery is not being able to visualize active blood flow. This technology allows you in real time to see tissue characterization, to see key critical structure, and to see blood flow. And then the fun part, which we'll get into, is we're already doing steps 1 and step 4 today with active site technology. This technology attaches to all existing scopes that are in every hospital in the world. So we're making this seamless workflow for our hospitals. What we do after we do that procedure number 1 to help reduce complications is then we collect de-identified surgical video. It's annotated, it goes to the cloud, it's done by ground truth data, then our machine learning algorithm takes over, and then we will be delivering back to our physicians in real time at the edge information that physicians haven't seen before. And we'll go into that more during this discussion. So thank you, Kian.
So these are excellent. Both Wave and Active Surgical's devices bring back memories of the Star Trek Tricorder. If you all remember, that was the device that would collect data, analyze it, and record it. And now that is becoming a reality, a vision from 60 years ago. So thank you for that. Next, I'm going to turn it over to Gabe Jones, co-founder and CEO of Proprio Vision.
Thank you, Kian, and thanks for the opening remarks, Dr. Stoudemire. So Proprio is a Seattle-based computer vision, computational vision company that was started by myself, a renowned neurosurgeon and a well-known computer scientist. And the idea was, could we take a bunch of sensors, put them in the operating room, stitch all these images together in real time, and then plug an Oculus or a VR headset into them, really to address the problem that surgeons can't see what they need to see, as Dr. Stoudemire was alluding to, access to data in real time. In building that, we understood that there was a series of problems that we were actually solving. It was more like mapping the anatomy in real time and understanding the positional relationships from each of those pixels, if you will, in the scene. And that actually became a really much bigger idea than a very cool surgical microscope. So here we've got illustrated on the previous slide, if you wouldn't mind going back. One of the first problems we discovered once we started pointing all those sensors at the anatomical regions. In spine surgery in the US today, there are over 1.6 million procedures performed. They're only done, 100% of them are done these two ways, freehand or navigated. And freehand means what it sounds like it means, which is an individual, a surgeon, relying on their knowledge and the feedback they're getting from the anatomy, mostly haptic, and then anatomical understanding, to do about 70% of those procedures. And the problem is that the surgeon doesn't have access to the information they need, so error rates are very high in that complex anatomy. And about 50% of those complex cases end up coming back for a revision, which is very expensive, results in lawsuits. It's terrible for everyone, of course, including the patient, the physician, the facility. And the solution today, really the state of the art, is navigation, which covers about 30% of those 1.6 million procedures. Navigation is 30-year-old technology. Think of two cameras looking at an instrument, a tool, and trying to track it in space in 3D. Well, you're mapping that against a 2D scan that is static in nature from a big O-arm or C-arm or intraoperative scanning machine. So you're really living in the past. You're thinking in 3D. The surgeon, we're asking them to translate between 3D and 2D in real time with a static image that is really incomplete. So exactly what Dr. Stoudemire said, this is the epitome of limited information and having to be creative in the art and science of practicing medicine. So we invented this system that, in fact, is more like a real-time GPS system for the operating room. Collecting a tremendous amount of data. We call it the Proprio paradigm because that was the most common thing that surgeons said. Once they tried it, they said, oh, this is going to change the paradigm. And really, I think it is the epitome of that edge compute where this wasn't possible 10 years ago. We started the company 6 years ago. Our friends at Intel and NVIDIA have allowed us to drop essentially a supercomputer in the OR and plug it into the cloud. And it really wasn't possible even 6, 7, 8 years ago, what we're doing now. If you wouldn't mind clicking to the next slide and show you a quick video of what that looked like. So this is a military grade mixed reality headset, a real-time feed from the anatomy. So instead of seeing everything in 2D, as you see on the right of the screen there, this is Dr. Browd, able to actually look inside the anatomy as he's operating and make, really with real-time decision support, better decisions, predict what's going to happen if he goes a little further into the pedicle of a single level of the vertebra here, and make a different decision that leads to a better outcome. And that's really the direction this is all going, is with edge compute in the operating room, plugged into the cloud, you should be able to kind of know the outcome before you get there. And that's going to be a game changer, I think.
Excellent. Terry in the audience is asking, you're all collecting a lot of data. Are there ways that you can monetize the data as the volume proliferates? And who ultimately owns the data, and what are what are your thoughts? I know Todd sort of showed the roadmap, but how are you planning to use the data? Is it just to educate your algorithms to get smarter, or are there independent ways to also monetize it?
Sure, I think data in healthcare and with payers and the FDA is somewhat of a bumper sticker. Hey, we need data, it's really important, until we prove facts. Data is only as good as how unique and how rich it is, and make sure we can produce outcomes with that data. But with that, yes, and the fact that data on the edge, Kian, I think is critical. There's a lot of data that's out there that tells you how to be more efficient in the operating room, or how to increase your case phase times and all these different things, but none of them are really taking data from the operating room and delivering it to the operating room, meaning real-time information where the physician can make decisions based on the data that pops on the screen, similar to Waze and GPS versus a traditional GPS system that might tell you you're 10 miles or kilometers from the airport. Waze might say you're 15 miles or kilometers from the airport, but I'm going to save you 40 minutes because up ahead's an accident or construction. What good data will allow systems to do will tell doctors that up ahead is key critical structure that you need to avoid. It's vessels, it's veins versus arteries, so you know whether it's arterial bleeding or what have you, so you can make critical decisions, understanding tissue characterization. And then it's up to us, and I'd love to hear from Kristen to really understand what's the confidence interval from a physician. When does a doctor believe in the data? And we could provide all the data we want, but when do you start trusting data over trusting science? And I think that's really the important. And then the monetization of data, Kian, is something that every company has thought of. I mean, who owns the data between a company and a hospital? If you have de-identified surgical video, et cetera, there's a lot of opportunities with data out there that you could start even using things such as blockchain and NFTs in making sure that there's data sharing the appropriate way. So, but I am curious for the audience as well to truly understand, when does data mean something to a physician versus science?
Kristen, any thoughts you'd like to share on first, how do all of these technologies sort of play into your day-to-day practice? And then what are your thoughts about the question that Todd asked in terms of level of confidence that would be needed?
Yeah, even though I'm familiar with all of these companies, hearing them presented is always pretty amazing. Having these tools available that can slipstream right into the workflow, as each of these three examples do, is so important. Adopting a new technology takes effort, it takes time, and then how much it changes your workflow can affect things as well. But when something can slipstream in and not add to your burden of work, that's huge. And I also imagine that as you become more familiar with the technology, you get more innovative about how you solve problems. So whereas before you had to approach a surgical problem or a clinical problem in one way, given limited information, as you develop confidence, as Todd was suggesting, in a technology, then you can start saying, hey, I'm going to try doing this a different way, and probably increasing your efficiency and your safety in doing so. And then Todd, you were asking about, when do you feel confident? I think, any surgeon who might be listening to this, we all felt a little bit burned by being oversold on some new technology that was tested in very controlled circumstances. And even if you went to training courses, again, it was in very controlled circumstances, and you don't really discover until you're actually using it just how it may or may not work. And so I think there's a point where we, for the most part, try to understand it the best we can, but give it a very short leash. And then as we are able to validate in our own experiences what the technology is, and that's where we start to get a comfort level there. So, but I think everybody approaches new technology with a, that sounds great, but let's see how it really works approach. And I think that that'd be the same for any of these.
Yeah. That's very interesting. And the comment that you made about the workflow, I think it's interesting to think not only that the new technology has to fit into the workflow, but it can also help evolve the workflow to a more efficient and optimal manner. So from all of our CEOs, I'd like to know, why is this happening now? What were the advances in technology or macro trends that make this feasible, make your technology feasible now?
I can jump in just because I'm already off of mute, if that's okay.
Sure.
Yeah, so this is really top of mind for us. So I mean, I look at those as sort of secular tailwinds, right? So none of us wanted COVID to happen. It's been terrible, but it also did accelerate a number of things that were already happening in the industry, right? So adoption of telemedicine and those kind of things were there, but the shortage of clinicians broadly, physicians more narrowly, and surgeons even more narrowly was already a trend, right? We're already headed towards something like 25,000 of a shortage in the US alone, depending on how you count that. And there's various drivers of that, but it's very real. Now you add in the nurse shortage with 1 in 5 nurses retiring or quitting or leaving the field over the last 2 years. And those are all very real, and you could see it reflected in the hospital finances. So that's another secular tailwind that should drive adoption of things that, as Kristen alluded to, make the procedure more efficient, fit into my workflow, and can drive me not just to do more surgeries or deliver more care, but to do everything more efficiently. And I think that's a big driver that's going to be, if we came back in 1 year or 2 years and had the same group and the same conversation, we would all be nodding our heads and say that wind really picked up. And I think that's really key. So the shortage, the real pain that physicians and facilities are feeling, the overall trend into the community, into ambulatory surgical centers is really very, very real. And we're seeing that in the numbers. And so that means certain procedures are going to happen outside the hospital, be reimbursed differently. The cost structure is different. ASCs know their cost structure better. And that's going to have an impact on products and uptake and adoption, as well as the mix of procedures that are done in those facilities. And I would add to that, in a very personal way, for our product, compute. As I was saying earlier in the little brief intro, the things that were possible before, pale in comparison to what we're doing now. And I'll just give you a quick thought for what we're doing. When we started the company, it took us over almost 2.5 minutes to render 1 frame of a light field image reconstruction for that kind of surgical microscope idea in VR. 2.5 minutes. Now we do that more than 10 times a second. And then we're registering those images, in 1.5 seconds or better. And that just computationally wasn't possible before. And so the ability to drop that into the OR, for each of our companies, there's a number like that over the last 5 or 6 years that's happened. We didn't invent that, NVIDIA did that, right? But we've worked with partners like that, as I'm sure my colleagues have here, to take advantage of those sort of secular tailwinds and really ride them. So I think that's a big part of why the time is now.
So that's perfect. So it sounds like it's a perfect storm between macro trends that are driving the kind of utility of a more efficient product combined with technology advances. So the two coming together make this possible. I mean, you talked about 2/3 of the world population that have never had an image done. Tell us more about how Wave is really manifesting this idea of computing at the edge by allowing greater access to imaging.
Yeah, and to build on what the others said, technological advances has really enabled us as a company to bring the cost of ultrasound imaging on the one side to a really, really affordable number. So when you talk about underserved countries, cost is a major driver. And we've brought the cost of imaging to a number that now they can afford to be imaged. And portability is another aspect that technology has allowed computation to happen at a scale that makes these devices super portable and ultra portable. And the other technological aspect for us is the smartphone ecosystem. So we are relying basically on a super powerful computer that every year is getting more and more advanced, and it allows us to bring, again, cost of the overall system down and bring technologies and expertise to remote areas, to underserved areas. And like Gabe was mentioning, the acceleration of telehealth because of COVID is not going to stop. And that is all empowered by the underlying infrastructure that more or less smartphones basically created. And we're riding that wave. And we're going to allow devices to be deployed in places that before it wasn't possible, and bring expertise to places that didn't have expertise before. And ultimately moving forward, bring expertise in the form of machine learning and artificial intelligence was just key for us also. And to touch on the data aspect for us, specifically as a company, we're more focused on what data can do to allow mass adoption and acceleration of the adoption of the technology, which is key for us. We want to create an autonomous ultrasound system that allows those nurses in places that don't have expertise to operate the ultrasound system, and data is super, super critical for us. So indirectly, basically allowing us to increase the rate of adoption.
Thank you. You know, someone in the audience is asking if the notion of edge compute or medicine at the edge is able to address HIPAA compliance issues. You know, those are patient privacy guidelines better than a central database would. Any thoughts there? I know Todd mentioned anonymized data. How do you handle data, and how do you make sure HIPAA requirements are met?
Well, I mean, the combination of HIPAA in today's world and what's those macro things that are happening in the environment, as Gabe started talking about, and you mentioned, Kian, as well. De-identified surgical video is one way. Anonymized data is another way. And then the opportunity to make sure that, I mean, the technology itself and the technology that we have, if you're attaching our technology, the active site, to a scope, and you pulled the scope out of the patient and flashed it all around the room, it would go black. The patient's name's not on there. It doesn't even show who's in the room. I mean, that's just the way that the system is set up, so you can cover that. But if you look at those big macro trends of the why now, I mean, you could have it's really cool to say we have autonomous robotics, but that's almost a solution looking for a problem. But when you look at the problems that are out there, readmission rates are at an all-time high. Patients coming back for routine procedures are averaging 12 to 15 days in the hospital. There's a shortage of global surgeons around the world. If you're lucky enough to be at Stanford and have Dr. Stoudemire do a procedure on you, or if you're unlucky enough to be somewhere else around the world and not have Dr. Stoudemire do a procedure on you, that's not necessarily the best thing for patients. So, the goal of technology is, while Dr. Stoudemire can't be everywhere, her data can be. And I can take her data plus a bunch of her friends from around the world and basically through crowdsourced data, and that information needs to appear on the screen from every doctor, no matter where they're practicing surgery. So you have the information through AR, through AI, machine learning, and sensing-based technologies, such as what we're offering. And the goal is to make sure that we can do that and deliver to the healthcare community something that makes sense because of the epidemic that we're facing with the shortage of surgeons globally, a shortage of a high level of complications that are having, plus being HIPAA compliant is critical. So I think it's a great question, but there are absolutely ways, and I guarantee that every company that's working on that data, as you would call it, data, has really already solved that issue, and working with the hospitals up front, that doesn't become an issue, and it's not even being discussed. Plus, we just have to prove that to the hospitals up front that we are protecting everybody.
So that's great. So in other words, you are essentially leveling the playing field. So we know in a lot of procedures, complications have to do with the volume of procedures that clinician or surgeon performs. Yep. But by bringing insights from experts, you're sort of democratizing that that skill set.
Yeah, and not to hog time here, but it's exactly, I've used the story of when my girls were 17 and they got their driver's license. They had like I said, a side view mirror that had a red light to tell you someone's in your blind spot. They had a rear view camera to tell you someone's behind you. They had a seat that vibrates, hopefully when they're not texting, when they're driving and they go out of the lane. But at the end of the day, I didn't have any of that. I'm still a better driver than them because of my experience, but they need to have the same information. So every doctor, whether they do 5 procedures a year or 500, needs to have the same information so every patient can have that confidence that their physician gets that information to then go make really good clinical decisions.
Got it. Thank you. So there's a question from Babak Pushanchi. He's specifically interested in Kristen and what she thinks about using these technologies to increase surgeon efficiencies and throughput, so more patients and more surgeries. And what about the potential risk for mistakes or malpractice cases as a result of relying on these technologies?
Yeah, I'll say for the first question, yeah, definitely efficiency can be improved. So I'm not a spine surgeon. the cases that are similar to that are when I do have very inflamed cases and I can't see the anatomy very clearly. The example that Todd showed with the mesentery of an intestine and the blood flow, we encounter those sorts of challenges all the time. And when you have a challenging case, you have to slow down and you have to march through very methodically, because you might not know where things are, you might not know how healthy the tissue is. And so it takes a lot of time and decreases your efficiency. If I know that what I'm about to cut through is in fact not a blood vessel or a critical structure, I can go a whole lot faster. And so what we've learned over the years is technology can make things faster. For example, with cholecystectomies, again, we used to do them all open, and then we moved to laparoscopy. You can get through a case pretty quickly. And I think that what we would find is as we start to incorporate more and more of these technologies, that yes, we get faster, we can do more cases. The second question you asked was around, I'm sorry, Kian, you have to remind me.
Risk of malpractice or potential mistakes as a result of relying on technology.
It's funny you asked that question, because I had an inverse thought as I listened to these technologies, is that there's a greater likelihood of them being protective from malpractice. And to give an example with the spine surgeries, as Gabe had said, they're having to do redo spine surgeries is very common. And that those are not low dollar lawsuits that are associated with that. And so having more knowledge can make you better. Now, is there a risk? I would say if you're relying 100% on a technology rather than synthesizing all the information in front of you, I think there certainly would be a risk. If you're looking at a structure and it doesn't look like what you think it is, and the data tells you differently, you still own that. To use the example of autonomous cars, if you're driving down the road and your Tesla doesn't tell you that there's a semi in front of you, then you still are responsible for not driving into that semi. But looking at these technologies, it all is a piece of information that fits together, and you have to reconcile all that data. And the nice thing that I'm hearing from all these products is that they're additive, and they help to bring the big picture together.
Excellent.
Yeah, and can I pile on that for 30 seconds? Because I think Dr. Stoudemire makes a really important point. A few numbers just to kind of put it in perspective. The average neurosurgeon is involved in some sort of litigation for about 24% of their career. That could be a case that they were involved in, or they're testifying regarding something. These are all involving depositions, and they're often 3 to 5 years after the actual incident itself. So they've got multiple layers of insurance. They are the tip of the spear, and this is not unique to only neurosurgeons. But 4 years later, you're trying to remember based on the operative note and maybe a pre-op and post-op scan, and understanding what kind of surgeon you were then versus now, and where you are in that continuum of your own growth and expansion of your capabilities over time. It's really just unreasonable for us to expect that person to be able to travel back in time and have a full picture of what happened, given the really sparse set of information we're providing. So yeah, simply, if we are doing all the things we should be doing in HIPAA compliance at the point of care in the operating room in our case, but each of my colleagues has a version of this, and we are engaging with the surgeon in a way such that we are delivering value, and it's all based on that trust. So it is the science, as Todd said and Kristen said. We should be able to make it actually less painful to prove what actually happened in the case, and reduce the number of litigations, which is a major time and resource suck for everybody, right? And frankly, do what we all want to do, which is get surgeons back to being able to make those decisions in a much more informed way at the point of care, and reduce these other obligations for them. I see it as a net positive. It actually could be quite transformative if we're collecting the data and providing it in a useful way.
Great. So we have about 5 minutes left. We're going to do a time travel exercise. I'm going to ask each one of you in 30 seconds or less, describe where you think the future of your company is. So where do you think you can be in 5 years? And then I'm going to ask Kristen to sort of do a reality check and say what would need to be true for your product to actually get adopted. So we're going to start with Amir.
Yeah, I think we're going to push for, again, enabling care delivery at the point of care. And that's a trend that has started, but is far from being complete. And I'll use 15 seconds of this time to give you a personal story of us being in urgent care about 2 weeks ago for my son. And we sat there for an hour. And then at the end of that, they told us to go to Stanford emergency medicine department because they didn't have ultrasound to perform on my son. And me being and doing ultrasound, I was like, this is just not happening. And then we were at Stanford for 8 hours at the end of a lengthy process that is costing the health system and patients and everybody thousands and thousands of dollars for a simple ultrasound that could have been done. And in 5 minutes, we all would have been relieved and done. So that's the shift that is happening. Provide the care at the point of care where it matters most, and shift care delivery from high cost, inconvenient places, go from hospitals to patients' rooms, go from emergency medicine to urgent cares and clinics and lower. So I love to see a day for us to be all at home, only if we are truly sick to be in the hospital. Other than that, be treated at home with the advances that all of us and other companies are making.
Excellent. So ultrasound being the safest image modality should be really in the hands of everyone. So that's great. So Todd and Gabe, please chime in and again, keep it brief in the interest of time, please.
Todd, you go first because I wanna one up you if you go first.
Perfect. Yes, I'll throw a low one here, low hanging curveball here. So I really think, Kian, the next major inflection point for surgical innovation and what active surgical is doing is when scopes and robots or any system can see things, whether it's anatomic or physiologic, that a surgeon cannot see on her own. And then today, if a physician is using a robot, the physician sees something, manipulates the robot to the proper position, and then the robot does all its magic. But I need the robot to complement the surgeon, not just augment the surgeon. And that's where we're going. And then also, not just with traditional critical structures, tissue characterization, lymph and sentinel node identification, tumor margins, and those are the things that active surgical is working on.
Excellent, thank you. Gabe.
What top that, Gabe?
Yeah, no, actually, I love that. There's nothing,
I'm just kidding.
Yeah, let's talk 25 years for a second and then come back, right? So what if we could predict—
And do it in 25 seconds or less.
Yep. Predict the outcome of the surgery, just during or before the surgery. That's amazing, right? Like let's make it so you can do that. Okay, let's walk back to a shorter term. You have to first make it quantifiable before you can make it predictable. So you have to measure everything you can possibly measure. And that's precisely what we're doing, because that is the building block for that prediction. And then after prediction, you make it extensible, right? This is, like Amin said, it should be everywhere. So if you can essentially guarantee the outcome of a particular maneuver within the procedure, then you're much more likely from a machine learning predictability standpoint and a reinforcement learning standpoint to redefine what is an instance, right? Basically, we're saying it's not 10 million surgeries, it's 10 million frames in a particular surgical pursuit, right? You're trying to accomplish an outcome. So the short of it is, I think over 5 years, we'll be able to guarantee a goal that the surgeon is pursuing within the case is the right goal, and how they're doing against those metrics in real time in the surgery. So they don't have to wait for a post-operative scan to know whether they succeeded or not. And I think that'll be big.
So I want to end with Kristen opining on these and tell us what would need to be true for this vision to actually materialize.
Sure. I also want to add something just in hearing everybody reflect on their thoughts. I think that with the information that's being collected, it's hard to imagine all the potential that we can do with it. Certainly improving the actual delivery of care at the point of care is one thing, but I'm in a teaching hospital and teaching residents how to do cases, and if you had a body of graphics that could really help teach somebody how to do a procedure, I think that that's a huge add that I could see developing into a whole separate industry in and of itself. I imagine, as Gabe, you were alluding to, linking this up to other data. So if you link this up to the EHR data, clinical outcomes, and you're able to precisely identify those things which were seen at the time of clinical care with outcomes, and that feeds back in the system and makes you smarter. So I'm just thinking the potential use of that information is enormous. Now the practical aspects, and you asked me to say like where.
And we're almost out of time, so please just dedicate like 10
Yeah.
seconds.
10 seconds. Yeah. I mean, everything has to work perfectly for stuff to come together, right? It has to have clinically good outcomes. It has to be usable for the physician, and it has to have it has to make sense from a business model perspective. I can't sell my hospital on something if it's going to be too expensive and it's going to add a lot to the other providers' workflows. So it has to make sense on multiple levels for these things to be practically adopted.
Well, thank you all very much. I think we could have gone on for another hour on this topic, but I want to thank everyone, thank the audience, and we'll finish by reviewing this legal disclaimer. Thank you, and we wish you all much success.
Thank you.
Thank you very much.